Okay, hello everyone. Really nice to see you here. I see your comments in the chat. Today I'm streaming from a usually sunny Batumi. My name is Alex, and unfortunately it's not so sunny as it usually is. And I'd like to ask you possibly to put a couple of comments in the chat stating maybe where you're from and what's the weather like, so we can get in touch and check that everything's fine, that we've got people watching us. Okay. So in the meantime, the topic of today's talk is code sharing. Let's get together. So today I'd like to say a couple of words about code sharing and present possibly for some of you a new solution on how sharing should be maybe possibly done. Oh yeah, seeing okay, Italy a bit cloudy, Lithuania gloomy weather. Yeah. So hopefully the summer is coming and we're all gonna be bathing in sunlight in a couple of days. Hello from Belarus, Almaty a bit sunny. Sunny is great. Okay, awesome. So let's get started. And so the topic of today's talk is code share. Let's get together. And I'd like you to present one possibility, one possible solution for sharing the code between repositories. I'm going to talk a bit about what we tried to achieve and how we achieved it, what problem did we try to solve, and then I'm going to do a small live coding session to show you in more details how actually the development process is going. And finally, we're going to have a small Q&A sessions. Please feel free to drop any questions that you might have in advance during this talk. And in the end, I'll try to answer them. And if not, I promise I'll do maybe a small research and get back and answer those questions a bit later. So let's get started. First of all, the setting and what's actually the problem. If you have been watching the trends in what was going on in JavaScript world lately, we have seen that the following web app stack choices have been made more and more often. So first of all, Node.js became a very popular choice for server side. More and more projects and clients are choosing this environment for their backend services. And secondly, TypeScript becomes de facto standard in enterprise development for obvious reasons, because it's more robust. But that leaves us with the following. Lots of web applications consist of client part and server part, which are written in JavaScript, and it's all wrapped up in TypeScript. And here is a small problem, which might be a bit annoying for some people. When you've got data sent from client to the server, it's basically the same data that server receives. And in TypeScript world, we have to write types and interfaces and like declare contracts for this data. But where should we store these interfaces? So should we store them in both like client-side and server-side repositories? That would be a code duplication, and code duplication is not a very good practice. So the first problem is how to share TypeScript types and interfaces between client and server. But more than that, we tried to solve a problem on how to make this development process quick, comfortable, and with immediate result. For example, if I want to change some interface, I want the front-end part to see those changes immediately. And in case there are some breaking changes, for example, if the contract changes, I want their types to be visible immediately. And so the TypeScript can highlight possible problems with the client-side application. And we started digging for options. And the first option that we've looked into just a bit was a Bit platform. So I'm stating like pros of this platform as a question mark. Possibly it's easy to use. We didn't investigate, we didn't put a lot of effort into investigating how Bit actually works, whether it's really comfortable, although I heard a couple of comments that it is comfortable to work with, because its cons is that, first of all, it's a third-party platform and it has paid plans for enterprise. So we knew that our client wouldn't accept this solution, so we didn't bother like investigating it properly. I'm just putting it here to highlight that this option exists, and possibly for your case, it might work perfectly. Second, the obvious choice is to create a custom npm package, which is, of course, it's easy to inject. We're all working with npm packages on a daily basis. It's got an established versioning system, and it's quite a mature solution. So in case anything goes wrong with your package, there are like a very high degree that this problem has already been discussed and solved. But on the other hand, it's a bit of a development overhead for just a simple task of working with interfaces, of sharing those interfaces and types, and maybe possibly some simple utility functions, because you have to like build your package, you have to publish it, you have to go to your main repository, you have to update the version, you have to install this dependency, and only then you might see results. Of course, there are ways to make this development process much quicker and better, but and npm was among our favorites. We almost decided to go with the npm approach, but we decided just to look a bit for more options. Third option was kind of using Yarn workspaces. Again, it's very easy to inject. It's very easy to set up. It's a quick turnaround because everything is in one workplace. But unfortunately, by definition, workspaces were meant to work for working with mono repositories, and we had a mono repository initially, and we used workspaces to share types. It was like a good experience, so we were happy with it. But unfortunately, currently we're breaking down into multiple microservices. Each is going to have its own repository, and we're breaking down into micro frontends. Each is going to have a separate repository. So Yard workspaces kind of became outdated and not quite suitable for us. But this experience came in handy. I'm going to talk about it a bit later. So our champion is actually Git submodules. What I'm going to present today is just to highlight that there is such a possibility, and turns out that not a lot of people are aware about submodules and about the opportunities they present. So I want to highlight in do an overview of what submodules are and how they helped us. To start with the definition, so a Git submodule is a record, blah, blah, blah. I don't like official definitions. They kind of look good on paper, but not very good for understanding. So let me break it down for you. It's just another Git repository inside your repository. Basically, you've got your main repo, and you connect, you create a submodule to a shared repository, and a folder is created in your repository, and in that folder is basically another Git repository, which is linked to, so your main repository is linked to a submodule, to a specific commit. And technically, you can have as many submodules, you can link as many repositories as you'd like, of course, until you reach the point where managing those submodules become crazy stuff. So basically, this is it. And let me dive in a couple of pros. So first of all, as I mentioned, your main repository references a specific commit, and no automatic updates happen. So whenever the remote repository in submodule updates, your main repository will not automatically track the branch. So it will remain referencing this specific commit in order to avoid unexpected breaking changes. So it's up to you to go and manually update this commit. And also, as for the versioning, Git submodules don't provide kind of versioning. If you want to switch to another version, you just go to the submodule folder and you check out the commit you'd like to have. Basically, this is it. If you want to go back, if something breaks in your application, you just check out to the previous commit, and again, you're good to go. The application works as expected. No third-party dependencies. So you don't need any plugins, you don't need any other NPM packages. All you need is Git. Inside the submodule, we work using common Git commands. Again, each submodule is just a separate Git repository, so all the stuff we use to check out, pull, push, commit work perfectly. IDE actually provide a very good support for Git submodules. I've been working in Visual Studio Code. It's pretty clear, pretty intuitive, awesome to work with, which I'm going to demonstrate in a couple of moments. And you decide where to put submodule folder locally. So if you're storing types and you have a separate type folder in your repository, you can specify that shared types are going be stored in this folder, and you will be working with this as just a local folder. So it's up to you to decide whether to put this submodule. And the great part is that basically it's a look and feel of a simple folder in your project. So from your perspective as a developer, from your code perspective, or from any build tool perspective, it's just a simple folder in your repository with some source code, with all the benefits that this look and feel gives you. Of course, there are a couple of cons because there are no silver bullets, and we also have to think about trade-offs. So first of all, it's a bit higher complexity and a bit steeper learning curve, because you have to, before starting to work on this project with submodules, you have to understand what submodules is and adapt a bit to a new development process. It has a bit of a complex maintenance because, first of all, it has detached head. So your submodules will be from time to time in a detached head state, again, because there are no automatic updates, and it will not track the branch. It is strictly for the reference to specific commit. And again, another con is that we're used to updating, when we're updating npm package, if we bump up like the major version, we know for sure that there are going to be breaking changes. Here, when you're bumping up to a specific new commit, you don't know whether these changes are going to break, so you have to manually check the contents of every change from your commit. You have to reference right now to the latest one and make sure that this does not break your application. So this is kind of the biggest cons of this approach. And so merge conflicts. You've got enough on your plate already resolving conflicts in your primary repository. If you decide to do like a branching strategy in your submodule, then again, there possibly be another set of merge conflicts. So like extra repository to maintain is also a bit overhead. But in our team, since we've got full stack developers who work at the same time simultaneously with front and back, we decided not to do any like pull requests, any branching for submodules and for these interfaces. We're just pushing to main branch directly. We're not doing any pull requests, and so far it has been working fine. And also, there are going to be extra commits for repo reference, because your main repository tracks this reference using a specific diff file. And each time you make a change to a submodule, you have to commit this file in your main repository just to keep this reference. So even if you don't do anything in your main repository, there might be an extra commit. And of course, no atomic commits for all changes. So you cannot push all changes into one commit, because these are separate repositories. Each of them has their own commit history, etc. So there will be separate commits. Some may find this also a bit overhead, so look out. It's also not suitable for very complex projects, for very complex structures. I can only imagine the hell that somebody might be going through when their submodules have nested submodules of their own, and how to keep this all like sane. For now, I have no idea, so I wouldn't advise to use this approach for some complex structures. There are other approaches, but I'm going to be talking about them a bit later. And of course, submodules do not provide like full Git functionality. Inside a submodule, it's a simple repository, so you can do whatever you want. But outside, as for the submodule itself, submodule functionality in Git, it does not provide full Git functionality. So for simple work, it's been more than enough. We didn't have any problems working with it. But if you do some advanced stuff with Git, or maybe you have jobs or CI/CD pipelines that do some advanced stuff with Git, I don't know, please check that it will actually work with submodules before taking this approach. Okay, then a couple of words on how Git submodules actually work. So let's start with this cheat sheet. I asked ChatGPT to generate a cheat sheet with all the commands, basic commands, and I think it's done a great job. So basically, for simple usage of submodules, you've got only a couple of commands. So you can add submodules, you can initialize submodules, and basically you can update submodules and remove them. Please notice, if you want to check out a specific commit, you have to go into the folder where submodule is located and use common git checkout. Same goes for pushing, adding, staging the files, committing and pushing, pulling, etc., etc. So pretty much the Git stuff that we understand and that we work with. But changing here and there in the console might be a bit like also a burden or an overhead. It's perfectly handled in Visual Studio Code. I'm going to show it again in a moment. So whenever you add a new submodule or you initialize a new submodule, this file .gitmodules is created in your main repository. So it has just the basic information of what's going on. You've got this local path, so where your submodule is stored in your main repository. You've got the URL to the remote repository and possibly a branch that has been used to initialize this submodule. This file is created once. It's not going to be changed, so you don't have to commit it all the time. You'll have to commit, you'll have to work constantly with this file. So this file has a diff extension, and the name of the file will reflect the submodule name. And basically, whenever you do something with a submodule, you check out another commit or you push a new commit, this file is going to appear in your Visual Studio Control and Git control, and you will see that this here contains the information about reference of your main repository to the submodule. Specifically, we see that here that commit this CEE5 has been chosen. So right now, your main repository in the submodule folder sees the content of this commit. And again, every time you do something, if you want to keep the result saved, you'll have to commit this file along with other changes that you might have made in your main repository. Okay, then let's move to the coding session, and I'm going to show you live how this workflow is going for us. So I've prepared a small exercise for our live coding session just to show you how the workflow with coding with submodules goes. So I've got two applications, two repositories. One is called app. So this is going to be our main repository, main application. And the other is shared node app, which we're going to use as submodule. So when I go to this app repo, I've got just a simple console log main app file. And let's do node in, we're going to do node index, and we're going to check that our application is working just fine, so it does what was intended. So if I want to add a submodule, I'm doing a git submodule add command. Then I have to go and just as the same way as we're cloning the usual repository. And this is the best part. We can specify the directory where to clone our submodule. So we can specify the folder, let's say like shared utils. Now you see that Git is cloning the remote repository. And when it's done, if we go to this main application, we see that we've got a new folder, shared utils, with utils.js file, exports a very helpful utility. And we've got a new file called git modules. This is what I've been talking about. Basically, we've got this new file, git modules. It's already staged for you. And we've got this shared diff file. So we understand that we've got shared utils submodule in this folder, and we're pointing to this specific commit. If we go and check here, we see 2210D, 2210D. Basically, this is the our commit. And if we want to maintain this connection, we have to commit and push these changes. So edit submodule on the main repository. Also, what happens if you check the source control, you see that there are right now two repositories. We've got the app, which is our main, and we've got shared utils, which is our submodule. And IDE, Visual Studio Code, is very good at tracking changes in both of them. So let's get and see how we can actually use these shared utils. So I just go to our console, our index file, and I do const helpful util equals require and shared utils and we've got utils, utils.js there. And we're calling this helpful util. Perfectly fine. So nothing to install, we just work with this folder as with any other folder in our code. We just import in something from that folder. And when we run, we see that we see the immediate effect. It's part of our source code. Now, if I want to make some changes, I just go into this folder, shared utils, and also please notice in the IDE, if you click here, this is part of the main repository. The branch here is going to be main. If I click on this file, it's going to be main branch of the submodule. So I've done a couple of times when I wanted to create a new branch and accidentally created a new branch for the submodule instead of the main repository. So keep track of that. And I'm going here and saying console log updated util. I've got updated util here. I'm saving it and I'm just running the code. And immediately I see the changes here. But what about the changes in submodule? So here we've got the utils file changed in this shared utils repository, and we can check those changes and we can work with it just as with any other repository. If we get to the app, first of all, the changes that we've done for the index file, and also since we changed this submodule, automatically a div file was created stating that we're no longer pointing to this specific commit, but this commit is dirty. So until we commit those changes, it's going to remain dirty. So let's commit the changes on our submodule. And let's see what happened. So since we updated this submodule, a new commit was created. Again, Git caught that. And it immediately referenced our main repository to the correct and latest commit in our submodule. So we can also commit those files and update it submodule. And we can push both changes to their origins. So right now we're in a state where our shared utils are updated, where everything is pushed to remote and our application works as expected. But what happens if somebody else does those changes? Then what we're doing, let's imitate this. We're in our shared dependency. Let's go to the utils file. You see that it was updated. Then we go here and we add in console. Console log remote changes. So somebody else was working in the same repository and made another commit. So when we get back to our application, immediately, like it's common git, nothing is changed. So we can just sync up and pull those commits from the remote repository. And immediately you see those remote changes. So our repository submodule was updated. So we see the remote changes immediately. We just run our application. We see those changes right away. But what's happened? This repository remains unchanged because it's kind of tracking the main branch right now. But here, the Git understood in the main repository that no longer we're referencing this commit here, we're referencing the new one which was pulled. And in order to keep this reference, we must manually check that it's exactly what we want. And we just have to commit this file as well so that we maintain the correct references and push it. So basically, this is it. Let's get back to the presentation. So the question arises, so what I've displayed right now, what I've shown right now is to how to manage submodule with like simple stuff like interfaces and types, but what happens if we want to share some code which has other dependencies, like maybe a React component or a Nest.js module, or like a third-party component with third-party library, something like that. And there is no simple answer right now for that. What I've tried to do initially is just like, for the sake of trying, I've tried to just install packages in a shared folder. Like you could use a post-install script. But this is not a very good solution because you end up having two node modules folder, one for your main repository and one for your submodule. And it's absolutely unclear dependency resolution. Your build system might get crazy. NPM and Yarn resolve those dependencies a bit differently, and having a sort of like nested packages on files is not a very good practice. If you have experience with such systems, please do write a comment. I'll be happy to hear and to know your experience. Also, you might end up having a bloated bundle because two node modules packages mean that even if the dependency is the same, it's going to reappear twice. Of course, like tree shaking solution like Webpack can solve this problem, but it might end up there. And also there are possible issues with using different instances of library. For example, if you have the same version of RxJS twice, but it still might break some instance of checks and mutations, and you'll end up having like unexpected bugs. So I do not recommend this solution. The solution that really looks promising is more complicated, but I consider this to be a better solution, is to create a mono multi-repo. So we'd want to set up our project as mono repository using Yarn workspaces, where each workspace is going to be this shared submodule. So in this case, we get all the pros and of course the cons of working with mono repository, and also pros and cons of working with submodules. I found an article, I'm going to share it a bit later, of the guys who had such experience. They say that it's a working experience. We're going to follow this road on our project with our team. And hopefully in a month, I'm going to acquire enough experience, and I'm going to make another talk, and I'm going to share our road during this path, and tell you what was the good parts and what was the bad parts, whether you should be going this road as well or not. And of course, a couple of watch points just to sum it up. So splitting existing shared libraries might be tedious. So if you already got a submodule established, if you want to split it further, it will be hard to do. So no automatic verification. This is what I mentioned before. There is no like versions. So you have to either implement some sort of commit message version in system of your own, or just manually verify that the changes you're introducing in submodule will not break your main repository. Learning curve becomes steeper, so you have to understand not only Git submodules, but also Yarn workspaces, how it's work and how it's organized together. And this is not a problem of submodules per se, it's more a problem of workspaces in general and monorepositories in general, that we also need to make sure that shared libraries and workspaces use compatible, ideally the same version of third-party libraries. So basically, this was supposed to be a short talk. Sorry for the technical details, technical issues. Here are a couple of useful links. So this first link is about submodules official documentation. Another good link about workspaces, Yarn workspaces, and the article I mentioned about using Git submodules and Yarn workspaces at the same time. All those links are going to be in the description to this video, so feel free to get back a bit later and check those. So I think this is it, what I wanted to deliver. I wanted to highlight that there is such a tool called Git submodules, give a quick overview of that, and open up a bit of a possibilities that can be done using Git submodules, like merging submodules and Yarn workspaces, because for me, it's looking quite promising. So if you've got any questions, again, you can write them in comments right now in chat, or you can reach me out in Telegram or in email. Even if you're watching this recording, please leave a comment, and I'll going to be checking for some time there, and I'll try to answer those questions as soon as possible. Okay, then let's get back and check if there are any questions. I'm gonna stop sharing and so again, I actually don't see any questions, comments, and I hear myself. Okay, guys, don't see any questions. If you've got any questions later, please reach out to me by the contacts I provided or leave a comment, and I'm gonna try to answer as soon as possible. It's been nice having you here. Have a great day.